Activities are an important part of the customer management framework. They can log any interaction a customer does with your system. For example, simple ones like just logging into the system, or more complex ones like placing an order. The customer management framework can track these activities, and then they can be used later on for calculating segments or doing any other kind of data science. But first things first, let's start with tracking the activities.
For tracking activities, we first of all need to load a customer, which we can, for example, load again via the customer provider. And then we need the activity manager, which is again a Symfony service which can be injected, and this activity manager provides us the method track activity to track activities. The track activity method expects an activity as parameter, and this activity can now either be the generic activity, which is shipped with the customer management framework, or we can provide any other implementation of an activity interface that suits for custom use cases. Let's start with the generic activity. And this generic activity expects a data array with a customer ID set, a type set, which is some custom type. So this can be whatever string you want to be it. And then we need an attributes array, which contains additional data that should be stored with the activity once tracked. And that's already all about it for tracking a generic activity. And let's just execute this code and open up the activity page of our custom, and there we see already we have some custom type activity tracked at a certain timestamp, and when we open up the details we see the additional attributes that were added to the attributes array. When you have some more complex activities or activities where you want to extract more data, then it probably makes sense to create custom implementations of the activity interface. In our demo application, we added two of them, the login activity and the order activity. And the benefit of these custom implementations is that you can provide a very clean constructor interface and extract all the data for building up the data array that should be stored with the activity directly in this implementation there. So for example, we can extract the customer and the order information we want to add to the activity storage table directly in this implementation here. So the tracking code becomes much cleaner. Let's, for example, just track the activity for a login. So it's just track activity again, and then say, for example, new login activity. In this case, we just add the customer as a parameter, and that's already about it. Execute the code again, and then we see we have already logged a customer login activity at this point.
The next aspect we need to discuss are customer segments. In general, customer segmentation is the process of dividing a big customer base into separate customer groups that are similar in one way or the other. And these customer groups are then used for marketing, for personalization, and similar things. In the context of the customer management framework, customer segmentation can be done with so-called customer segments. The actual idea is quite simple: just create data objects, customer segments, and assign them to the customers. Actually, we have two types of data objects. We have the customer segment group, which describes a group of segments, for example, gender or customer type or interest groups. And then we have the actual segments, which, for example, can be male, female, and so on. In terms of assigning the segments to the customer, we differentiate between the manual assignment, the manual segments, which are assigned manually by the user itself or by an editor, and on the other hand we have the calculated segments, which are calculated with so-called segment builders. More on that later on. Before we dig into the code and see how to work with segments in code, let's have a look at our demo application and how things are set up there.
In our demo application, we have set up a couple of customer segment groups with their corresponding customer segments. And as already mentioned before, customer segment groups as well as customer segments are just standard Pimcore data objects. Their classes are created during the install of the CMF with all the necessary data attributes. And it's of course possible to extend these class definitions with additional data attributes as needed for your use case. Which data is stored here? So which segment groups and which segments are necessary for your application is really depending on your application and on your use case. So what you see here is just an example in the context of our demo application. In your application, you will most probably have your own segments and your own segment groups. To see how the segments are assigned to customer, we can, for example, open up the customer view here. And there we see already all the segments that are assigned to certain customers. Some of them have more, some of them has less. Let's maybe just open up the Betty Rubble, which has quite a lot of segments assigned. And yeah, there we see these are all calculated segments based on the segment builder. We will discuss this later on. And what we also see here is that we not only have the segments assigned, but we also have a couple of meta information available, which is a timestamp, which can be set when the segment is assigned. So this helps us to implement, for example, automatic cleanup if a segment assignment is very long ago already, then it might be not relevant anymore. And then the second meta information is a segment application counter, which helps us to weight the segment assignment and so identify more relevant segments and not so relevant segments that are assigned to a customer.
When working with segments in your custom code, the first thing you need to look at is the segment manager. It is the API to use when working with segments. It provides methods like creating segments, like assigning and merging them, and others.
The segment manager is another Symfony service that can be injected to wherever you need it, for example, into your controller actions. And the segment manager interface then provides lots of methods for working with segments. That means from getting them by ID, getting segment groups by ID, creating new segments, but also merging and applying the segments to the customers. Let's maybe just start with creating a couple of segments. Let's maybe just create a group. Segment manager, create segment group, my group, for example. Then we can segment manager, create calculated segment, for example, segment 1, and we need to define the group here. And then we maybe have another segment, so we can here really just create all the segments we might need. The segment manager creates all the segments and also places them into the correct folder. That means, let's maybe just execute this. In the configuration of the CMF, we can specify to which folders the segments should go to, and the segment manager, of course, takes account to that, and in this case creates our segment group in the calculated segments section here and adds these two segments we just created. Next step would be now to make sure that the segment builder is not executed on every customer save, but is executed on this asynchronous execution of the segment building process. For that, we just change the segment here and of course set the return value of this execute on customer save method to false. And yeah, when we now go back again to our customer, save it again, we would expect that nothing happens, so that the customer segments are not changed in any way, and that looks good. And yeah, now we need to execute this asynchronous segment building process, and this is done with a console command, with the spin build segment console command, which should be of course executed as a cron job somewhere. And yeah, now the process was executed, and we would expect that our customer has now some additional segment assigned with the segment async based on this asynchronous execution of our segment builder. Again, our segment builder is still not very intelligent, but it shows how implementation can be done. And now all the magic, of course, needs to be added in this calculate segments method, where we need to do the calculation, where we need to decide whether additional segments should be assigned to the customer, where segments should be removed from the customer, and whatever needs to be done with the segments of the customer.
In the customer data object, we already saw the manual segments and the calculated segments. For calculating the calculated segments, the CMF provides a concept called segment builders. Segment builders are Symfony services that implement a certain interface and are responsible for calculating the segments of a customer based on any information necessary. They can use the data attributes of the customer itself, like gender information, like address information. They can use the activities of a customer or any other information source that is available and can be used. There are a couple of built-in segment builders shipped with the CMF, but the most common use case will be that you create your own custom segment builders. For doing so, a couple of things need to be considered.
Implementing a custom segment builder always starts with creating a PHP class that needs to implement the segment builder interface. And this segment builder interface requires a couple of methods to be implemented. And well, yeah, we need to discuss a couple of them now. Let's start with the execute on customer save method, because this method requires the decision when the segment builder should be executed. There are two options. First option is to execute it on every customer save, and the second option is to execute it asynchronously in the segment building process that is executed via a command that should be executed via cron jobs. There are both ways possible, and there are use cases for both ways. Sometimes it might be handy and useful to execute it every time on the customer save. Most probably, most of the segment builders will though be executed asynchronously, because first of all, this has performance implications if you do it synchronously on the save of a customer, and second, there might be also other events that should cause a calculation of the segments. The asynchronous execution of the segment building process always takes place for a customer when this customer is in the segment building queue, and a customer is added to the segment building queue every time the customer is saved, every time an activity is tracked for the customer, or when it's added manually with the segment manager, where there is a method to add the customers to the segment building queue. For now, let's start with an synchronous segment builder, so we just return true here. And then let's have a look at the other methods. The getMame method should just return a unique name for the segment builder. And then there are two more methods that are important. First of all, the prepare method, which only makes sense when the segment builder is executed in the context of the asynchronous segment building process, because there the prepare method is executed at the beginning, and you can do some preparation stuff like loading data load, like doing some calculations that don't need to be executed for each customer separately. And then the other method, calculate segments, is then executed all the time for every customer. So it's executed for the synchronous segment builders on every time we save the customer. And of course, in the asynchronous context, is also saved for each customer separately. For our test segment builder, we leave the prepare method empty and just implement the calculate segments method. And actually there now we need to do some calculation for segment building. So we need to retrieve the data. We need to implement all the magic where we want to decide whether a segment should be added and how many segments should be added to the customer, or maybe segments that should be removed from the customer. For now, we just do a very simple thing. We just get the segment from the segment manager, just maybe create the segment on save in our segment group we created before, and then we use the segment manager to merge the segments here to the customer. We just add our segment, and we don't want to delete any segments. We don't want to specify any nodes. We maybe want to set the timestamp and also set the application counter. And that's already it. We have implemented our segment builder, and what's missing right now is that we just need to register the service as a Symfony service. This we do the same as we do it for others here in our demo application. So just create the service definition, and the important part here is that the service definition needs to be tagged with the CMF segment builder tag, because this tag tells the CMF that this is a segment builder that should be executed when segment building is taking place. Now everything is set up, and when we go back to our customer and save this customer once more and reload, we would expect that the segment builder was executed and the additional segment was added to the customer. And there it is. When we save it once more, then we would again expect that the segment builder was executed and that our application counter is increased. As I said before, the segment builder now doesn't make much sense because there is no actual calculation. It's quite simple and just adding the segment, but it still shows quite easily how a segment builder can be built and integrated into the customer management frame. The next step is to assign segments to a customer. For that, we don't create the segments anymore, but just load it from the segment manager. There we use this get segment by reference, say segment 1. Then of course we need a customer to assign segments to. For that we use again our customer provider, and then we are already ready for assigning the segments. This is done again with the segment manager, because there is a method that is called merge segments, which merges the segments that we want to add with the segments that the certain customer has already assigned. And for now we want to just add the segment. Then we can also specify segments that should be deleted. Right now we don't want to delete any. Then we can optionally provide any hints for the notes so that we can see what happened to the customer in the notes. For now we also say no to that, but what we want to do is to set the timestamp in the metadata, and we also want to have the application counter set to the segment assignment. And once segment merge is executed, we also need to save the segments to the customer, which is a separate call here. And that's already about it. When we now execute the code and reload our customer, then we will see that the additional segment is added to our customer, the timestamp is set, and also the application counter is set. And when we now, for example, execute the code once more, then we also will see that the segment counter now is set to true in this case. So assigning segments to customers is pretty easy, just use the segment manager. When a customer data object is saved, the customer save manager kicks in. It is responsible for all the actions and hooks which are executed by the customer management framework and are configured there. It consists of three major parts, which are the customer save handlers, the automatic object naming scheme, and the customer save validators. Let's maybe start with the automatic object naming scheme, which allows you to configure a consistent naming scheme for all the customer data objects. And this is configured in the customer provider section of the configuration tree of the customer management framework. There are actually three options that need to be set up. There is a parent path, which is the root folder for all the customers in the data object tree. In this case, it's set to customers. There is an archive directory, which is the directory where all the archived customer objects go into. And then there's the naming scheme, which can take out certain attributes out of the customer data objects and set up a further folder structure and also define the data object tree. And then it has to be enabled in the customer save manager. So let's just set the enable automatic object naming scheme parameter to true, and then the naming scheme is applied automatically on saving. Let's try this. We create a new customer there, set the country, for example, and the first name and the last name, and execute this. And when we have a look then at our customer list, there is the new customer there. And when we see where it's located in the tree, then we see already it's organized in the AT folder for Austria. We don't have set any zip code, but the object key is based on the first name and the last name. The second aspect of the customer save handler are customer save handlers. Customer save handlers are services that are registered on the Symfony container with a special tag, which is customer save handler, and can be used to normalize or modify any customer data before it is saved. Let's have a look at our demo application where we have registered such a save handler, which is the normalize zip save handler. And when we now load our customer and set the zip code to a certain value and save the customer again, then we will see that our customer itself has now the zip value stored, but the zip code is already normalized and the AT in front of the actual zip code got removed. What we also see now is that the automatic naming scheme got applied again, because now our John Doe customer is located in a special folder for the zip code we set to the customer. The third aspect of the customer save manager is the customer save validator. This customer save validator allows us to validate the customer before it's saved and also prevents of saving any invalid customers. It is again configured in the customer management framework configuration tree, where we have actually two parts of it, because the customer save validator also checks two things. First of all, it checks required fields, where we can configure certain fields or field combinations that need to be set in order to allow a customer to be saved. In this case, either the email or first name, name, and zip need to be set in order to allow the save customer to be saved. And the second thing is checking for duplicates. which is again configured in the customer safe validator by activating this check for duplicates flag. And in addition to that, we also need the customer duplicate service where we can configure the duplicate check fields. And again, there we can specify multiple field combinations. In this case, for example, we have set either the email or first name and last name and zip code and street need to be equal to consider a customer as a duplicate. Let's again have a look at our demo application and how we configured it there. We see the customer safe validator is configured that we check for duplicates and that the required fields are either email or first name and last name. And the duplicate check fields are either email or first name and last name and street and zip code. So when we now create, for example, a customer which just has a first name set and try to execute this, we'll get an exception that we don't have all the required fields set up. So when we go back and, for example, now also set the last name, we should be able to save the customer again. Now let's create another customer, maybe another John Doe, and set now also street and zip code to the customer and create it one time. It's of course possible because we don't have another customer with the same first name, last name, street and zip code combination. But when we execute the action once more, then we see that we already have another customer which has the same zip and street combination. When we now, for example, say some other street here, then the save should be possible again and the new customer is not considered as a duplicate anymore. So this shows you how the customer safe validator checks for the required fields and also checks for the duplicate fields if configured.
Now that the customer management framework is installed and configured, it's time to get hands-on and work with some customers. Since customers are standard Pimcore data objects, working with customers is pretty much like working with any other data objects. There are only two things to consider. First, use the customer provider to create and load customers. And second, there is a customer safe manager that kicks in every time a customer object is saved and executes a couple of actions and hooks. But let's start with the customer provider.
To get an instance of the customer provider, just use dependency injection and get an instance from the Symfony container. And once you have this instance, then you can use the customer provider, for example, to create a new customer here. There you can also set a couple of values right away, and then you get a completely standard Pimcore data object with all the setters and getters you know already from the API, and also of course, for example, for the save method, and just call the save method and your new customer is saved. You also can of course use the customer provider to get customers, for example, by ID. Then again you have a standard Pimcore data object, can use the setters and the getters for modifying or getting the data, and again using save method to update existing customers. What you also can do is that you use the customer provider to get an active customer by email, which is probably one of the most important methods of the customer provider here, where you get active customers by email, which is of course pretty handy when you're doing logins or something like that. And again, you get a standard customer data object. Again, you can of course use the setters and the getters to modify the data or get the data, and again the standard methods for updating and saving the customers. What you also can do is that you create listings of customers, Again, use the customer provider here, get list, and what you get here is a standard Pimcore data object listing. So again, same methods as you know already. For example, set conditions, where you can say first name like whatever, for example. And in addition to the standard data object listing methods, there is one additional handy feature of the customer provider, which is add active condition, which adds the active condition to an existing data object listing. By the default implementation, it actually just says active equals true, but there might be more complex active conditions. So this also is an abstraction of setting active customers or not. Long story short, working with customers is pretty much standard working with Pimcore data objects, with the addition of this customer provider that abstracts you the creation and the loading of customer data objects.
Of course, this PHP API cannot only be used within controllers, but also within CLI commands. To see that, let's just create another example with the Assets API and create a CLI command. For CLI commands, Pimcore just uses the Symfony command module and provides you to interact without any user interface with Pimcore. Let's just create an image update command, which needs to extend the abstract command of Pimcore console, and there you need to implement at least two functions. First function is a configure function, which allows you to set, actually to configure your command, like setting some name, asset update command, for example, set some description, modify some assets, and in this case, this place you also could configure certain variables, parameters, all these kind of things. The much more interesting method though is the method execute, which contains the actual logic that should be executed when starting the command. And in this command, we now just again modify some assets. In this case, we don't load the asset with an ID, but we use an asset listing, new asset listing. An asset listing is, as the name already says, a list of assets which you can configure, like set some conditions, I don't know, file name, like let's just only use JPEGs here. You can also set, of course, a limit, order, so the typical paging stuff and these kind of things. And then let's just iterate with an for each loop over the asset listing and do some stuff. Let's, for example, write line processing asset get ID, and let's actually do some stuff. For example, just add a new metadata which is called expire, say the type is date, and we just put in the current time here and say asset save, and in the end we maybe output write that we are done again. So at this point it's a good point to clear the Symfony cache and rebuild the container so that the command is registered properly. And once this is done,
we should see our new command in the bin console list here. And there are, of course, a lot of Pimcore commands. There are a lot of Symfony, Doctrine, and these kind of things commands. And somewhere there should be our app asset update command. And now we just execute this command, and we see that certain assets with certain IDs are now updated. And let's double check, go back into Pimcore backend interface, open the certain asset, and see if the custom metadata was added here. We have expire here added, and we also see an additional version which now was created, which added the expire timestamp here. Let's take a look at how we can use this PHP API. And for that, let's just first create a new product within a simple controller action. And to do so, let's just say we have a product here and say this is a new demo product. When we create a new data object, we need to provide a few informations for Pimcore that Pimcore can organize and put the new object into the correct place in the tree. This is first of all that we need to define the parent, set parent. In this case, I can either provide a data object that should be the parent, or as an alternative, let's just use a service that creates as a folder by a path. Let's just say demo import product, for example. And the second thing that we need to define, at least define, is the so-called key, which is the name that is shown in the tree. Let's say this is an imported product 1 or so, and then optionally I can define if the product should be published or not. By default it's not published. When I set this published to true, then of course it's published. And then I already can start and filling the data that I want to put into my product by just calling all the setters, like set name, for example, new import product. Then we have a set description, for example, we say, for example, set price and set some price, and then in the end we just call the save method and the new object is saved. And now when we go into our browser and execute the controller action, we hope that we see no error message, it's just a done message. And when we go back into Pimcore backend and reload our tree, then we would expect that we have this import folder here with product, and then we have this imported product with all the data that we just imported via our controller action. Of course, controller actions are not the only place where I can put my source code and where I can execute and, for example, import new products. I also could create a command for our console application. And yeah, to do so, let's just create a new command here in the command namespace. Actually, for the command line stuff, Pimcore uses the Symfony console and command module, and yeah, just adds a few additional extensions to it, but actually it's the Symfony command module. A command always needs to extend an abstract command, and then I need to at least extend two methods. First method is a configure method, which just allows me to set certain meta information to my command. For example, I can now here set the name. This would be now generate products, for example. I can, for example, set description, import
some new products. And at this place I can also specify some variables and options that I can provide when calling the command. The more interesting function is though the execute function, and this execute function is the place where actually all the business logic comes into. And in this case, we just import, for example, a few products where we say, let's just import about 100 products in a loop here. Let's just paste the code we had before in our controller and add the correct use statements here. And maybe let's just add an additional output here. Importing product somewhere. Important at this point is that we need to make sure that the key is unique within one folder. So the full path of an element should be always unique. This is not just for products, but also for assets and data documents. Let's just put some information here too. And then when we go back to our command line and maybe just execute the cache clear command of Symfony, that we make sure that our new command is registered correctly. And then as soon as this is done, we can execute the bin console command, and there we see all the commands that are available. There are lots of Pimcore commands, of course. There are a few commands from other bundles, from Symfony, from Doctrine, from different external tools. And at some point there should be our new command, which is the app generate products command. And now when we execute this command, it runs through and imports, for example, products from an external source. And now when we go back to our Pimcore backend and reload the tree here, see our import folder with the product folder, and there we see that we imported now about 100 products. And that shows pretty much how we can use the PHP API and import data into the system, and how easy this is to do. And actually this is also the typical way how to get data into the system. Just create a command, put in all the information, read some external source like an external file or an external service, get all the data and put the data into the Pimcore system via the PHP API. Next thing is that we utilize the Pimcore PHP API to manage assets, to create new ones, to update existing ones, and to delete existing ones. To do so, let's just switch into the IDE and get started. Don't let you disturb you with the controller setup I just did here. We discussed this in later sessions. The important thing is what I'm writing right now. First off, we want to create a new asset. So let's just create a new asset. And there are two things you need to set up or tell Pimcore that Pimcore can manage the asset correctly within the tree. And this is, first of all, I need to specify the parent. In this case, we just specify parent ID 1, which is the root node. So our newly added asset will be located directly below the root node. And the second thing is that we need to set a file name. So this is my imported asset, JPEG, for example. And then, the third thing is already that we specify some data. So set data, file get contents, for example. Let's look somewhere in the internet where we find a nice cat picture
copy image address, for example. So there would be now your image source, and then let's just call save function, and this should be already it. When we now execute the action, hope we don't get an error message, and go back into Pimcore backend and reload the asset tree, we see here our newly added image with the correct binary data. Of course, I not only can create new assets, I also can update existing assets. To do so, let's just go back to our controller, the test controller, comment the existing lines and create some new ones. For example, we want to load an asset. There are a few ways of loading assets. For example, I can load it by path or by ID. Pimcore provides you a few static helpers for that. In addition to that, you also can work with asset listings. We'll have a look at that later on. So let's just get the asset, which has the ID 75. And now let's say we want to change the binary data. So just set data, file, get contents again. Let's see if we find some other cat image, which is nice. Let's just put this one here, copy image address, and again call save method, and this should be it. So let's just again execute the action, hope that we don't get an error message. Looks good. Go back into Pimcore backend, reload the asset, and see that we have now a new image here in our preview. Of course, we now see versions. Since we didn't do this with a certain user, the user is system, so all API interactions are done with the system, with the user system, and there we can see, okay, what changed and what data was changed when we executed our script. Just to give you one more example, what can be done with the API is, let's use again the existing assets and add some meta information. So add metadata. Name is my data, for example. The type will be a simple input, and there is some additional meta information, and again save the asset and job done. Let's just execute again the action. Again, no error message. And now when we reload the asset in Pimcore backend, we should see some custom metadata here that we just added now to our asset. And again, we have additional versions here, and in the versions we also see the meta information here, which we don't have in the older version. Of course, I not only can update assets, I also can delete the assets, which is, you maybe already figured it out, just calling the method delete, and then the asset is gone again. Let's just execute our action, and now we reload the tree and we see that our asset is gone already. This is now a very simple example of how to work with the PHP API, but this is a quite important one because this already explains the basic principles of how to work with this PHP API of Pimcore and how this is structured. So it's really object orientated. You always have a PHP object for some kind of entities like assets or data objects or whatsoever, and you can just call getters and setters and all the normal object-oriented programming stuff, and then you have the save methods or the delete methods to save or delete the data. Of course, I also can use the API to update existing products. Actually,
it's working the same way as importing new products, except that we use existing ones. And for loading existing products, there are actually two options. First of all, there are several static helpers like get by ID or get by path or get by some attributes of the data object, and then load the data object. Let's just use quickly get by ID and use the ID from an existing product here and say this is our product. And then of course I can again set some attributes and at the end I again hit the save button, and of course the attribute is then set to the existing product and the product is updated. So let's just execute the command, go back to Pimcore backend, reload the data object, and see that we now have some modified name in the data object here. When we have a look at the versions, we also see that, of course, also when I create the data and modify the data via the API, versions are created unless I deactivate them. And since there is no actual user when I do this via the API, the user in this case is always the system user. And with the data objects here, I also can compare two versions and see which data has changed and what happened. Of course, I cannot only update existing products, but I also can delete existing products. Would work the same as, for example, also for assets, not call the save function, but just the delete function, and then an existing data object would be deleted. Another option to get existing data object is to use the listings. And I just want to show you this in the context of a controller action. Let's say we want to load a product listing, which is just a new demo product listing in this case. And the listing is actually now an interface, an API, where I can load a list of products with the typical functions for lists, like I can set a certain conditions, I can of course set a limit, can set an offset for implementing paging functionalities, all these kind of things. And once I have set up my listing, then I can iterate through my listing, for example, via an for each loop, and do some stuff here. And let's, for example, just iterate through all the products and create a reduced data object array. And let's say, for example, we want to have our ID here, and we want maybe the name, product, get name, and the price. Here. And at the end, we don't return the standard response here, but we return a new JSON response and just assign this data here. And what now happens is that we have created a simple REST web service. Like we just return a list of all the data objects that we have imported before into our system. Of course, now I can make this a bit more interactive, that we, for example, assign the request here and say we want to set a condition where we set price more than a certain data array, and let's say from price as a parameter we want to accept. And now when we call our data object command or route in the browser and say from price
equals no 50, for example, then it filters out our list and only returns data objects that have a price bigger than 50, or let's maybe make 58, and then the amount of returned data objects is quite reduced. Again, a really simple example, but this example also already shows how simple it is to create data interfaces, REST services, these kind of things with Pimcore. Actually, it's just a few lines of code utilizing the Pimcore PHP API, putting in some parameters, and then working with the data. These were now a few simple examples of how to work with the PHP API. This PHP API, though, is one of the key concepts of Pimcore. If you like, so this is the daily bread of Pimcore developers, because this PHP API allows the developers to really interact with the system, get data from external systems into the Pimcore system, modify, update, manage the data within the system, and of course, expose, export, and get the data out of the system and deliver it to different output channels. You can use the PHP API to populate templates. You can use the PHP API to create simple REST services and really work with the data in the system. So the PHP API is really one of the key concepts and one of the most important parts of Pimcore, yet it's still quite simple and easy to use, which is also a key concept of Pimcore, of course.
To see how resources can look like, let's have a look at our demo site. Let's go to more stuff, developer corner, thumbnails page. Here you see different thumbnails that are calculated on the original image, like different ways of changing the dimensions, size of an image, like applying on overlay to an image, rounded corners, and also applying some additional filters to the image. The thumbnails are always calculated when the first time they are required. The first time some client is requesting a certain thumbnail of an image, then it's calculated and it's then cached to the file system. So the second time or third time a thumbnail is requested, then it is delivered directly from the file system. Once the original image or the thumbnail configuration changes, Pimcore automatically cleans up all the affected thumbnails, and then the thumbnails are recreated the next time they are required from a client system. Thumbnails are stored in the file system as I mentioned before. So let's have a look where they are stored. Let's go to file system under public var folder, not in the assets but in the temporary folder. And there you see this thumbnail folder. And this has the same structure as the assets folder. And inside these folders, you see all the generated thumbnails. To request an image thumbnail, let's go back to our IDE and see how this can be done. So I'm going to use the example action here. So first, let's get the asset object. So for that, we'll call get by IDE on asset image class. And let's pass the image ID as a parameter. Now on this object, we will call get thumbnail method and pass the thumbnail name as a parameter on this asset object. So once we call this action, we get the media part to the image thumbnail. So let's go back to the browser and run the action. So now you see the path to the image thumbnail that we have just configured before. Now let's go back to the image thumbnail configuration and let's see we want to change the format from auto to PNG. Then let's save it and go back to the action and rerun it. So now you see the file format changed from JPEG to PNG. Thumbnail itself is again the PHP object, which in this case has just the toString method overridden so that it delivers the path to the thumbnail. But for example, I also could just call getHTML method on this thumbnail object. And in this case, the whole HTML tag is rendered. So Pimcore just delivers the image that is defined before. Now let's inspect the source code. So we see we have the image picture tag with the source and source set information, which is applied automatically there. So now let's go back to the image thumbnail configuration, and let's say we don't want to apply grayscale filter. So we just want to scale the image and round the corners. So let's save the configuration and let's reload the action. When we reload the thumbnail again, then we see it takes a bit longer because Pimcore recalculates the thumbnail in the background. If for whatever reason automatic cleanup didn't work, or you want to clean up thumbnails manually, there are two options available. The first one is to open the image and click this option in the toolbar of an image editor, which clears all the thumbnails of the current asset. And the second option is in the settings cache menu, which is called clear temporary files. Be careful with that option because this option clear all the temporary files of Pimcore, meaning also all generated thumbnails. So let's say if you have heavy traffic websites with a lot of images and with a lot of high resolution assets that needs to be converted to certain thumbnails, this can increase the load of your server significantly and maybe even kill your server because too many thumbnails generation processes are started at the same time. If in general creating thumbnails on the fly is a problem and cause of the server load or of the huge size of the original assets, there is a CLI command that allows you to create thumbnails asynchronously. So the command is pimcore thumbnail image. And this command allows you to generate thumbnails of certain assets within certain folders for certain thumbnail definitions asynchronously and pre-calculate the assets so that they are not generated on the fly. Instead, return the already generated thumbnails. There is one important asset topic left, and that is called thumbnails. Pimcore follows the single source publishing principle, and this of course applies to assets and images that are managed within the asset module. That means an image should be stored only in one version, best quality version available. But of course, different output channels need different versions of a certain image. Some higher quality, some with lower quality, some with bigger size, and some with smaller size. To cope up with these requirements, Pimcore provides the functionality that is called thumbnails and thumbnails transformation pipeline. This allows you to define and create version of a certain asset and deliver it on the output channels. Let's have a look how these thumbnails are configured in the Pimcore backend. Thumbnails are configured in settings section of Pimcore. Here we have the image thumbnails and video thumbnails. So both applies for images and videos, whereas image thumbnails of course have more features than videos thumbnails. Let's go to the image thumbnails and let's create a new image thumbnail and let's see what can be configured. Of course, you can specify a certain name. You can specify a description. You can specify a group, which basically puts it in the folder group for thumbnails. So this is a meta information. The more interesting stuff is, for example, the format that you can specify. So Pimcore automatically generates the thumbnails in the configured format. And then you have some additional advanced settings like image quality, resolution, and so on. And a so-called transformation pipeline. This transformation pipeline allows you to create certain transformation steps that a thumbnail should go through before it is delivered to a certain output channel. These transformation steps can be simple, like resizing the image and also rotating it, setting a certain background color, rounding corners, putting some overlays and watermarks to it, even applying some simple filters to the image. You can, of course, combine these transformations. For example, let's say scale by height and specify a certain height, and then say put some rounded corners to the image, and at the last apply grayscale filter. These transformations are applied step by step to the image thumbnail, and at last the resulting image will be returned. If you're dealing with responsive web applications, you can take the benefit of media query feature of thumbnails. With this feature, you can define different CSS media query breakpoints, and you can define transformation which will be applied based on the conditions met.
Hello and welcome to this session of Pimcore Insights. This time it's all about assets. The asset module is, if you like so, the dumb part, the digital asset management part of Pimcore, and allows you to manage all kinds of binary files within Pimcore. These binary files are organized similar to a file system in folders and files within these folders. Let's have a look into Pimcore backend and see how assets look like in action.
The assets are managed with the asset tree and are organized in folders. Every folder can have one or multiple asset files, and for each of these assets files we have a preview available, or at least for most of these files. Some of the previews are generated directly, like for example for these images here, and others are generated with third-party libraries, like for example with the Office documents here. We are using the LibreOffice component, and if this component is not available in your system, then also the preview of the assets is not available here. Also, what you can see here quite good is the multi-tab interface of Pimcore, which allows you to switch between different assets really easy and really quick, and of course not just between assets, but also between other document types like documents and data objects.
Hello and welcome to this session of Pimcore Insights. This time it's all about extending Pimcore. Pimcore provides a couple of ways of extending it, and since Pimcore is pretty much a standard Symfony application, most of the ways follow Symfony standards, like events, event listeners, bundle development, and so on. We also already discussed a few ways of extending Pimcore, like just adding additional libraries and packages via the Composer JSON, or injecting custom functionality into the Pimcore data entities, like the parent class functionality of the data objects and the class mapping functionality of the data entities in general. Besides the big things like events, event listeners, and bundle development, Pimcore also provides a few small points where to change the default behavior of Pimcore and where to extend Pimcore. One of which, for example, are the Pimcore constants that define the locations of certain directories like logging directory, assets directory, versions directory, and so on. And these constants can be overwritten by just adding a custom constants file, which is located under app constants PHP. And in this file, you can define all the constants with your custom values. Which constants are available within Pimcore, you see in the bootstrap PHP file of Pimcore. Most of them are, as I already mentioned, just directories like the assets directory or configuration directories, versions directories, these kind of things. And depending on the use case, sometimes it might be useful to override the default values with some custom values. What is also sometimes quite useful is the possibility to add some custom logic into the startup process of Pimcore before the kernel of Symfony is loaded and booted. And this is possible by just adding an additional PHP file, which is called startup PHP and located in the app folder, so app startup PHP. And there you can put in any additional logic that you might need for your application, like, for example, defining the trusted proxies for the request object. And of course, you can also add additional functionality here, like, for example, influencing the default environment handling and a couple of other things. Database-wise, the block data type is not stored in the Pimcore typical way in a column-wise approach, which means that each attribute is one column in a database. The block is just serialized into one big column, long text column in the data object table. Let's just have a look how this looks like. Let's open up the store table of our test class, and there we see already we just have one column, which is the comments column, as a long text. And when we have a look at the data, there we see that the entries of the comments are just serialized here in this database column. This, of course, has the consequence that filtering or searching for comments data in this case, or in general block data, is not so easy and not so nice as filtering for other data types. The next group of data types allow you to repeat a set of data attributes multiple times within a data object. Sample use cases for that would be to model comments within a blog entry data objects, or to model comments within a product data object. Pimcore ships with two data types that allow you to do so, first of which is the block data type. And this block data type we'll have a look at right now. To do so, let's just switch back to our data class definition, and let's just add a block data type, which is again located in the structured section. And you have to add the block data type here, give a name, for example, comments in our use case, and then similar to the localized fields, just add attributes that should be repeated below the comments node here. So for example, right now we, say we want to add a name here, and then maybe let's just add a comment and maybe a date, and save this class. And when we now go back to our data object of this class, let's just reload it and have a look at the comment section. And there we see that we have this plus icon and can add comments multiple times, and the block data type allows us to attach multiple comments to one data object. The block data type also supports data inheritance of data objects. So when we just add a new sub object here, then we see that the comments also are inherited here. They are not inherited field-wise, but really just the whole collection of attributes. That means once I override one attribute within the whole block, the inheritance for the whole block is broken and interrupted. In terms of additional settings that can be specified on the blocks data type, there is one thing that is worth mentioning, which is the lazy loading flag here, which allows you to specify if the comments should be loaded every time the data object is loaded, or if they should be loaded just when you call the getter on the comments attribute. This, of course, depends on the use case that you are using the blocks for, but sometimes this allows you to significantly improve the performance. To activate or deactivate, to install or uninstall Pimcore bundles, you either can use the extension manager within the Pimcore admin interface, which lists you all the available Pimcore bundles and allows you to execute the corresponding actions. In addition to that, you also can use the console commands that Pimcore provides, which are all prefixed with Pimcore bundle, and there we also have, of course, commands like listing, enabling, disabling, install or uninstall certain bundles. For now, let's just enable the Academy bundle we just created to make sure that all the functionality is available and also all the JavaScript files and CSS files are injected into our Pimcore admin interface. And when enabling a Pimcore bundle, Pimcore of course enables the bundle and then also executes the assets install command of Symfony and also clears all the Pimcore caches and the Symfony container and rebuilds the container. Once your bundle is enabled and if necessary installed, then all the bundle functionality is available to your application and you can use it either for additional services and controller action routes, these kind of things, or also in addition to extending the Pimcore admin interface. And to do so, Pimcore provides you, similar to the events on PHP side, also with events on JavaScript side, which you can of course find in our documentation. And there you see the list of all the available events that we have in Pimcore, which are generic events like uninstall event or, for example, the Pimcore ready event. And then we also have events when elements like assets, documents, or data objects are opened or saved with pre-save and post-save, pre-open and post-open events. And by listening to these events, you can interact with the system and, of course, inject your custom functionality. Implementing event listeners for these events is pretty simple. You just have to provide a JavaScript file, which we have already some blueprint in our generated bundle here. And this JavaScript file needs to implement a class, which needs to extend from Pimcore plugin admin class. And within this class, you can implement all the event listeners by just adding methods with the name of them. For example, here we have already the Pimcore ready method, which listens, of course, for the Pimcore ready event. And in this case, we would just alert and make some message. And once this is activated and Pimcore is reloaded, then it should print out this alert message. Let's see if this is working. Reload Pimcore and hope that the alert message pops up, and there it is. The important thing of our Academy bundle class here, JavaScript class, is that of course it has the event listener methods like the Pimcore ready event, and the second important thing is that it implements the initialize method where it registers itself to the plugin broker of Pimcore, so that Pimcore knows, okay, this is an event listener that potentially listens to certain events that are fired within the system. So let's do something more practical and more useful and not just annoy the editor and popping up alert messages. Let's, for example, add an additional button to an object editor which provides additional functionality. This can also be done, of course, with an event listener. In this case, it would be the Pimcore post open object event. And in this event listener, we can access the whole editor tab of the object and modify things like, for example, adding additional buttons to the toolbar. Actually, we have already one article in our best practice section of the documentation which exactly does that. And let's just get the code here and discuss this code a bit in detail. So we have our post open object method, which is the event listener. We get the object, which is actually the whole object editor tab. And there we can access all the information that is available. For example, we can access all the data and check, for example, for certain classes. So let's say we only want to have our button in product objects. And then we access the toolbar and add an additional button here. And this is actually not special Pimcore code, it's plain XJS code. And this is also something that you will experience pretty soon once you try to extend functionality in the Pimcore admin user interface. You will have to implement XJS, but it's pretty much plain XJS. And yeah, once you have understood this, it's pretty easy to extend additional functionality, like we do here by adding a new button here, which has a certain text, which has a certain icon class, which has a certain handler, which is empty right now. And yeah, then after that, we just make sure that the Pimcore layout is refreshed so that the button is also rendered. And let's go back to the admin interface here and just reload again and hope that it is working. Let's open up a product object and see what's happening, and there is our additional button that can now provide additional functionality to the user. This is pretty much a blueprint of how to extend the Pimcore admin interface and add additional functionality, and to get inspired how to resolve things and how to implement certain things, just have a look at the Pimcore core code where we do all the things, and all the functionality that is provided within Pimcore core can be used as a blueprint, as an inspiration of how things can be implemented and how things can be done with Pimcore JavaScript and XJS.
The second big option to extend Pimcore are bundles. Bundles should be used when sharing functionality between different applications or different projects is necessary. Pimcore uses the native Symfony bundle system, which has two big advantages. First, you don't need to learn anything new, and second is that you can benefit from the whole Symfony ecosystem. In addition to the native Symfony bundles, there are also so-called Pimcore bundles, which are an extension to the Symfony bundles. They implement a special interface and allow you to interact with Pimcore a bit more. For example, they will show up in the Pimcore Extension Manager. You can activate and install them via the Pimcore Extension Manager, and they also allow you to inject additional CSS and JavaScript files into the Pimcore admin user interface. To start with bundle development, Pimcore provides a bundle generator, which can be installed in your development system and should help you to get started a bit easier.
Once installed, this generator bundle provides a generate command that is called Pimcore generate bundle, and this generate command asks you a couple of questions and then generates a bundle skeleton with the typical structure and also with some examples in it. The first question is if you want to share this bundle across multiple applications. If you put yes there, then it also asks you for a bundle namespace. If you put no there, then it just asks for the bundle name, which can be, for example, Academy bundle. The next question then is about the target directory. As target directory, we recommend a different directory than the source directory for the bundle development to not interfere with the application code and also not to mess up with the autoloading. But of course, you can choose any directory here, so also, of course, the source directory. Let's keep it at the bundles directory. And then the last question is about the configuration format. We keep here annotation, and then the bundle generator generates us the bundled skeleton. Before we can get started, we need to fix two additional things. We need to tell Composer that it should autoload the bundle sources from this bundles Academy bundle directory. And then we also need to tell Pimcore to look in this bundles Academy directory for Pimcore bundles in order to list our Academy bundle then in the extension manager. Let's quickly do these two things. Copy this line and add it to our Composer JSON in the autoload PSR4 section. And then we copy these lines and then we just put them into a configuration file, for example in the config YAML here, in the Pimcore namespace, where we just define the search paths here. These two steps are only necessary now during development. When installing bundles via Composer, that can be configured with the Composer JSON of the bundle. To see some examples for that, just have a look at the Composer JSONs from our bundles at GitHub, for example the Data Hub bundle or the Bundle Generator bundle or any of the other bundles. So finally we are nearly there. Don't forget to start Composer dump autoload here, and then we are ready to start using and developing our bundle.
The Pimcore bundle structure follows the standard Symfony bundle structure. For example, when we have a look at the Academy bundle that we just created with our generate command, we see that we have here a controller folder where all the controllers should go into, where we have a dependency injection folder where all the dependency injection things for Symfony, like the extension implementation and also the configuration implementation, if you have one, go into. And we also have a resources folder where all the resources go into, like all the configuration resources or the template resources if we have one, and also all the public assets that should be available to the outside world via the web server, like additional CSS files, like additional JavaScript files that should be, for example, included into the Pimcore admin backend interface. And then we have our bundle implementation class, our Academy bundle, which in the case of Pimcore bundles extends the abstract Pimcore bundle or at least implements the Pimcore bundle interface. And this Pimcore bundle interface defines a few methods to provide meta information for our bundles, like nice name, like description, like version information. It also provides you the possibility to define an installer that allows you to install and uninstall the bundle with the Pimcore extension manager, and therefore also allows you to inject certain installation tasks like creating additional tables or creating additional data object class definitions or whatsoever. And then you also have the possibility to define so-called JavaScript paths or CSS paths and edit mode JavaScript paths and edit mode CSS paths, which define JavaScript files or CSS files that should be injected into the admin interface of Pimcore. In our sample class, we have one method overwritten here, and we inject an additional JavaScript file into our admin interface. In addition to the bundle class itself, there is one more Pimcore bundle specific thing, which is in the area of configuration. Of course, you can follow the standard Symfony pattern for registering additional configuration files, which means that you define in your extension implementation all the files that should be loaded, like we have it here with our services YAML file. And in addition to that, Pimcore provides you certain auto-loading functionality, which is defined as follows. If in the Pimcore folder there are additional files like a config file or routing file or services files, then these files are loaded automatically by Pimcore and are added to the Symfony configuration. Hello and welcome to this session of Pimcore Insights. This time it's all about data objects. Data objects are the master data management part of Pimcore, or if you like so, the PIM part of Pimcore, and as the name already suggests, are quite a key functionality. With data objects, structured content can be managed. That means every content that follows a certain structure can be managed and put into relation with each other within the data objects module. May it be blog entries or news entries or persons or products or product categories or orders or any other data type and entity you might need for your data model. Pimcore doesn't set you any limits in terms of the entities, and so allows you to set up really flexible individual data models and knowledge graphs that you need for your use case. Data objects themselves are again organized in a tree with folders, with subfolders, with objects, with possible sub-objects, and each data object again has a certain editor with a toolbar, with tab panels, and with options to manage the data of each data object. So this follows the same principle as we know already from the assets or the documents. The structure of each data object is defined in so-called class definitions. And these class definitions can be created directly within Pimcore backend interface in this data objects classes menu. And in this class editor, you can set up the data model. let's just create a new data object class, for example, a demo product class, to see how this works. In this editor now we define two things. First of all, we define which data attributes should be available for our demo product class. And the second thing is that we define at this place how the editor for our demo product objects should look like. So let's just start with the editor, add a panel here, and then we add the data components. The data components can be selected from many different data types. We'll have a look at a few of them in more detail, and of course most of them are also documented in the Pimcore documentation. For our demo product, let's just keep it simple for the beginning. Let's start with a name attribute. Besides the name of the attribute, you can also define additional options like the label, like a tooltip, like how it should behave in terms of should it be mandatory, should it be visible to the editor, these kind of things. And then I have also some data type specific settings like a certain width or a column length, how many characters should be allowed for this field. So there are a lot of different options I can choose from. Let's maybe add a few additional fields, maybe a VCBig field for a description, and let's just add an additional number field, for example, for price. And then let's save the product or the demo product class. And once we have saved our class definition, we can create objects from that type. And to do so, let's just maybe create a folder here for demo, and then we create another subfolder for products, for example, and then we create demo product objects. So we have a demo 1, for example, where we define some demo 1 texts and some content, and this costs a certain amount of money. And then we have another demo object, which is demo 2, and again, of course, I can put in all the data that is relevant for this data object. So this is quite a simple example of how to set up a data object class and create objects from that. But this simple example already shows quite good how simple the principle is, but yet how powerful this tool can be in terms of managing structured data. For example, let's say we also want to categorize our products. And for that, we create a new entity, which is called demo product category, for example. And let's make really just a very, very simple class definition here. We just add one data attribute, which is called a name. And then we save that data object again. And yeah, same principle as before. Let's just make a folder with categories, and then we can add our category 1, for example, and maybe let's just add another category, just that we have 2 here. So this is another category, for example. And now, of course, the next step would be that we want to put the products and the categories into relation with each other. And this can be done with, again, quite a simple functionality by just adding additional data attributes to our demo product class. And in this case, we choose a relation data type, in this case, a many-to-many object relation, where we say this is our categories field, and in the type-specific settings we can specify which classes should be allowed. In our case, we want to allow product categories, and let's say, for example, we want to show the ID and the name of the category in our field definition. And then we go back to the demo product object, reload this, and there we see we have another field here, categories field, and now we can assign either via drag and drop, or we can also utilize the search dialog and assign all the categories that should be assigned to our product. This what I just did shows two quite important key functionalities of the data objects. First of all is the relation options, so that I can put data objects into relation with other data objects, and of course also with assets and with documents, and therefore I can build up all the knowledge relations and actually a knowledge graph that holds all the knowledge that is necessary for building up experiences for my users. And the second thing is that I showed quite implicitly is that the data model and the data classes are not fixed. They can be extended and can be adapted to new requirements, to new needs, and therefore can grow with my application, can grow with my organization, and so I really can grow my whole data model with new requirements and with new environments. Because it's so easy, let's just even more extend our product data model. Let's maybe also change the layout a bit and say we want to create a tab panel. And there we have, for example, base data. And then we add another tab which contains all the relations. And then we add another tab that contains media data, for example, just to see how the relations also work with with assets, for example. And there I can now add, for example, an image gallery, and use this image gallery as product images actually. And again, we save our class definition, we go back to our product object, reload this, and there we see already now our editor looks a bit more complex. We have this tab panel here in the top where we have base data, where we have our relations, and where we have now the image gallery, which again can be used, of course, for adding relations to assets, and either via drag and drop or again via the search dialog I can assign different images to the gallery here. So I think you already get the principle how the data models are set up. Of course, you are not restricted to just a few fields. Classes can have hundreds of attributes, or at least dozens of attributes, and you can choose from many different data types, like different text data types, like different number data types, like different date data types, like selection data types, media types, relation types, geographic types, CRM specific types for managing person or personal data, and additional more complex data types. And by combining these data types wisely, by combining different data entities with different data object classes and putting them into relation with each other, you can really build up any data model with any data to manage that you need for your use case.
Hello and welcome to this session of Pimcore Insights, which is all about documents. Documents are the CMS part of Pimcore and allow you to manage unstructured content based on templates and deliver this content to different output channels. The most common output channel, of course, are websites. But since Pimcore doesn't restrict you in any way when it comes to templates, documents also can be used to deliver content to, for example, digital signage systems, or even create print deliverables with Pimcore's web-to-print engine. But let's first have a look at Pimcore backend and see how documents work in detail.
Like assets, also documents are organized in a tree, and from this tree you can open up the documents in an editor. The editor again has a toolbar with the most common managing features like saving, like deleting, like renaming, unpublishing, reloading, etc. And then there are tabs for working with the documents, and these tabs are like editing, like a preview tab, like a SEO and settings tab, like a navigation and properties tab. And there are also tabs which we know already from the assets, like the versions tab, like a scheduling tab, like a dependencies tab, like notes and events tab, and like the tags tab. The most basic concept of documents is that they follow the MVC pattern. That means each document has to have a controller action and a template defined, and this definition takes place here in this SEO settings tab, in this controller section, where you can specify the controller and the template of the document. The controller and the templates do not ship automatically with Pimcore. They need to be created on installation base by the developers.
In the last part, we learn how to configure event subscriber to add custom conditions to our DataHub API listing query. Now let's see how we can add additional checks for data provided on mutations. So suppose we want to add an extra check for categories in the create car mutation. So user needs to provide categories data in the create car mutation. So for that, let's use the same event subscriber class that we implemented for queries. So for this, we are going to use mutation post build event, and let's add a method name on mutation post build, and let's add our custom logic to add extra checks on the field input field on mutation post build. And we need to provide mutation type event parameter here. So now we need to fetch the configuration from this event object so that we can change the mutation schema and we can provide that additional check on a required field. So let's call get config on the event object. And now we need to traverse the fields on this schema definition. So first we need input schema. So for that we need to traverse the array config fields, then mutation query, which is create car, and then args, and then input. So now we have the input schema of our mutation type. So now we need to use the input type configuration, so which is an array. So fields and categories. And now we need to change the type of this categories field schema. We can do that by providing the type here and wrapping the existing type inside type non-null, which is a required field for the GraphQL. So now this will override our existing input schema definition, and it will make this categories field required. Let's check iExplorer now. So if you reload the iExplorer screen, you will start seeing the error here, which is the required error for the categories field because it is not provided in the input block. And let's run the query. So you see that we have required error for the categories field. Now let's see some working example of data hub events. Suppose we want to add custom condition to our cars listing query. So we already have a filter on car class, which is sports cars. And now we want to add some condition on object type. So we want to have only actual cars in the list. So for that, we can use listing event. So we can use listing preload event here. And this event provides listing event object. So for that purpose, you can either use Symfony event listener or event subscriber. So here I have implemented an event subscriber class and registered this class in services YML with the tag kernel event subscriber so that Symfony identifies this class as event subscriber during kernel execution. So now we need a method for our custom logic. So let's add on listing preload method, and we need to provide listing event parameter to this method, and we can fetch listing object from this event object by calling getListing method, and we can provide some condition on our listing object by calling getClassName is equals to car, so that we only apply condition to our class listing. And let's add a condition param for our car class listing. So we want to have a condition here on the object type, and we want to set the value for the object type to actual car. Now we need to set the listing object back to the event object. And at last, we need to bind this method to the listing preload event. Now let's rebuild the Symfony container to be sure that our subscriber gets registered. And now let's run the query. Events in Data Hub follows the same approach as of Pimcore events, which implements the standard Symfony framework event dispatcher. These events are fired at different places, allow you to hook your custom functionality so that you can modify and change the API default behavior. So for example, you can change the query response before it is returned from the API. You can add custom condition to your listing queries, or you can update the information while creating objects with mutation queries. All these Data Hub events are defined as constants in events classes, which are linked in the documentation. So let's have a look what are some available events. So we have pre-built, post-built query events. We have pre-built, post-built mutation events. And we have executor events, which are fired before and after a query is executed. And we have preload listing event, which is fired before the listing is returned in the API response. And with the help of event listener or event subscriber, you can hook your custom functionality.
There are now a couple of differences between blocks and field collections. The first difference we already saw, because the field collections are defined in a central place and not inside the data class definition, and that of course has the consequence that field collections can be reused over multiple data object classes. Another difference is that you are not restricted to one collection type within one field collection attribute. That means let's just add here another field collection definition and then go back to our class definition. And there we see that we can allow multiple types here in this field collection comments field, which then has the consequence that the user can choose between different types of collections entries and can just add multiple entries of both types to the field collection data entry. Another difference between block and field collections are that the field collections don't support data inheritance. So when we just have stored now our parent data object with some entries here and some name, and we open up the sub-object, then we see that the collections data type is empty, in the opposite to the blocks data type, which inherits the data. The reason why the field collections do not support data inheritance is in the database, because in the opposite to the block data type, the field collections again follow the Pimcore typical database modeling approach, which means that for each data attribute there is one column in a separate database table. Let's have a look at this one here. So let's just go back to our database administration, and then we see already that we have some additional database tables which are object collection, underline field collection name, and underline class ID. And in these tables here, you see again we have a column per attribute, and the entries of the field collection are stored row by row, and each attribute has its own database column. This of course has the consequence that you can easily query and filter for the data that is stored within the field collections, but in terms of the data inheritance, it would be much more complex to support some kind of query tables for field collections, and that's the reason why data inheritance is not supported for field collections at the moment. The second option to repeat a set of attributes within one data object are the so-called field collections. In terms of the user interface, the field collections look pretty similar, but in terms of concept, field collections are much more powerful than the block data type. Let's just switch back to our class definition and see how field collections are defined. Again, we add a new data attribute out of the structured section, which is called field collections. Let's just move it up there and say this is the collection comments, for example. And yeah, in the opposite to the block, the field collection attributes are not defined just within the class definition, but there is one additional section where field collection can be defined, and this section is again in the menu data object field collections. And there you can define system-wide the field collection definitions, which of course has the consequence that field collections can be reused over multiple data objects, which is an advantage over the blocks. Let's just create a command field collection, and the definition of the field collections look pretty much the same as for data object classes. So again, you can choose between layout components and data components, and in terms of the data components, you have lots of data types available again. Actually, most of the data types except structured data types are not there all the time. And let's, for example, just again add a name field and a comment field and maybe a date field. Save this field collection and then go back to our class definition and scroll down in the collection comments data type, and there we can now specify which field collection types should be allowed at this place here. Let's just save this and open up again our data object, and there we see already we have our collection commands, and there we can now add additional commands pretty much similar to the field of the blocks data type.
Hello and welcome to this session of Pimcore Insights. This time it's all about importing data into Pimcore. In essence, there are two approaches for importing data into Pimcore. The first approach is utilizing Pimcore's APIs, may it be the PHP API or any of the web APIs provided by the Pimcore Data Hub. When importing huge amounts of data, using the PHP API might be the best way to go, as it provides greatest flexibility and best performance. For more insights on that, have a look at our documentation pages about working with the PHP API and also at our Academy courses. Of course, as a downside, when using low-level APIs, this means more work for developers when importing the data. And this brings us to the second approach, which is utilizing tools and frameworks that allow you to configure imports by configuration and clicking buttons rather than by writing code. One of these tools is the Pimcore Data Importer, which allows you to configure imports for data objects, set up sophisticated data mappings, and execute these imports manually or on a regular basis. So it's possible to connect external systems like ERP systems, CRM systems, or any ETL tools and any other data sources. And in addition to that, it is also possible to import and update from data files that you prepared manually. And how this is done, I'm going to show you now.
Once the data importer is installed, the configuration of imports takes place in the Data Hub configuration. So there we can add additional import configurations. And besides some general settings, every import configuration has 3 major configuration sections, and we will go through all of them in detail in the course of this session. First, we need to configure the data source, so where the data to be imported comes from and what format this data has. The second section is all about import settings, which is for sure the most extensive one and contains settings for the location of the imported data objects, for mappings, etc. And then the third section is all about the execution of the import.
Hello and welcome to another session of Pimcore Insights. This time it's all about customizing the appearance of Pimcore backend user interface. Especially in the context of data objects, Pimcore provides several options to optimize the user interface for different use cases. You can define different views on data objects by using custom layouts. You can define additional trees by using custom views and using perspectives to putting all the things together and also optimize the menus. In addition to that, Pimcore also allows you to define custom icons and custom tooltips for data objects depending on the content that is in the data objects. Sometimes there is the requirement to add additional functionality to the generated PHP API, like for example providing some special calculations or providing some convenient getters and setters and so on. Of course, you must not change the generated PHP files themselves, because then your changes would be overwritten the next time you save your class definition. But Pimcore provides you a few other ways to inject your custom functionality to the PHP API. Hello and welcome to another session of Pimcore Insights. This time it's all about reporting. Pimcore offers several ways of integrating reports and visualizing them to its users. We can classify these options into 4 major groups. The first group I would call inline reports, and this allows you to create inline reports within data objects and visualize information directly within the data objects. These can be used, for example, to visualize the data quality of a certain object. The second group are the custom reports, which allow you to create centralized reports based on different data sources and share these reports with several users or user groups. The third group I would call the iframe reports, and they allow you to create completely custom dashboards, reports, or whatsoever, and integrate them into the Pimcore backend interface via iframes. And the fourth group I would call the custom portals, which are completely independent of the Pimcore admin interface and allow you to visualize reports, dashboard, whatsoever outside of the Pimcore admin interface, and therefore, for example, optimize them for mobile presentation or other stuff. These can be used, for example, to create executive summaries, executive reports, and other things that you don't want to have in the Pimcore backend, but directly outside. Depending on your requirements, on the use cases, and of course also on the budget, you can choose between these options, pick one or a combination of these options, and create your custom reporting solution for your application.
Hello and welcome to another session of Pimcore Insights, Introduction to Data Hub. If you have reached this point, you already know how to fetch data from Pimcore using Data Hub API query schema definitions. Now, it's time to see how we can utilize mutations to add or update data into Pimcore. Let's take a use case that we want to add a new car object from external system into Pimcore folder under Upload, Data Hub, and later on we update some information on the same object. So first, we need to define mutation schema in the Data Hub API config. So I'm going to use the same API endpoint that we have used for the query schema definitions. So let's add car entity to the mutation schema. And let's allow create, update, or delete operations for the car entity. And then click settings to add attributes to this mutation definition. So let's add some attributes that we want to update from the API endpoint. And click apply. And afterwards, we need to provide workspace permissions on the new folder, Data Hub, where we want to create, update, delete new objects. And click Save. Our API endpoint is ready with mutation schema definition. So now we can form the query in IE Explorer. Let's start by typing mutation, create car. So for this create car mutation, we need to provide some required parameters so that the object can be created in Pimcore. So let's provide these required parameters now. So we need key here, which is an object key in Pimcore. Then parent ID for the target parent in Pimcore, and publish status. Let's set it to true. And we can also provide some input information that should be updated when an object is created. So let's provide some input here for the new object. So let's provide the name, new car, description. This is new car. And let's provide car class. So we want to create new sports car. And some manufacturer information, which is an object relation. So we need to provide ID here for the manufacturer and the type. So for many-to-one or many-to-many relations, we can provide type here like object, document, asset, but that should be allowed in the class definition. So in the create car mutation, we can also request some information. Like here we can request success status, and we can also request some information from the newly created object. So let's request ID and let's run the query. Awesome, our new object is created with ID 1338 under folder upload data hub. Our new object is still a virtual car, as you can see it from the icon, which is gray. How about if we want to make it an actual car? And for that, we need to update object type property to actual car. So for that, we need to use update query mutation. But first, we need to add this attribute to our schema definition. So let's add object type attribute to the schema definition, and let's click save. And let's reload our graphical interface. So now we want to update our object, so we will use a different mutation query. And for the update car query, we need to provide the ID of our new object, which is 133H. And just like create query mutation, we need to provide input argument here with the information that we want to update. So let's provide object type here, and we want to make our new sports car an actual car type. And let's also request some success information and some output information like ID. And let's run the query. Awesome, our object is updated. Now let's check if the information is really updated. So now you see our new car is an actual car because the icon is red now.
One still very important channel of marketing communication are newsletters, personalized newsletters to be more specific. And therefore also the CMF supports you with creating and sending personalized newsletters. There are two approaches for that. The first approach is to use the built-in newsletter tool of Pimcore, and the second approach is to integrate with an external newsletter provider. Let's start with the internal newsletter tool of Pimcore.
The built-in newsletter tool is located within the Pimcore documents as a special document type, which is called newsletter. The newsletter documents are Pimcore documents, and therefore you can use all the concepts that you know from the documents also for newsletters. That means you can use edit tables to allow editors to specify content, to add texts, to add images, for example. You of course also can use the area bricks to allow the editor to compose the content of the newsletter out of different parts. And well, the only thing you need to consider is that you have a newsletter, an email document here, and that the markup needs to meet the requirements for the emails. Other than that, you have the full flexibility and the full power of all the things that Pimcore offers. In addition to the HTML content, you also can specify the plain text here. And so you can really put in all the content that is necessary for the newsletters. Once the content is set up, you can switch to the sending panel, where you can then send the newsletter to your recipients. And for that, you need to choose from one address source adapter, which is responsible for getting the addresses that the newsletter should be sent to, and also for sending the newsletter to these addresses. In the context of the CMF, there is one additional source adapter, which is the CMF Customer Segments adapter. And this adapter takes the customers that are managed within the CMF as the source for the addresses and allows you to additionally filter them for segments and also for some additional flags like the newsletter confirmed flag. And yeah, so let's for example just send this newsletter to our female customers here, and then you can send the newsletter to all the customers. At this point, it is important to know that the content, the newsletter itself, is rendered for every customer that it is sent to. That means it's easily possible to customize and personalize the newsletter to every customer it is sent to based on the data that the customer has available. So that means that in the template itself, you have the customer available, the customer data object available, and so you can react to the activities, to the segments, to all the attributes of the customer and personalize the content of the newsletter there. And so this built-in newsletter tool is already quite a powerful tool for sending newsletters to customers.
Besides its benefits, the built-in newsletter tool has its limits too, especially when it comes to big numbers of newsletter recipients or DevOps topics like making sure that the mail server is not blacklisted. For these use cases, we recommend to integrate with an external newsletter system. The CMF has a module to do so and also ships with a couple of default implementations, like from MailChimp. The integrations always have two parts. The first part is about the synchronization of the customer data itself. This can be configured in the Symfony configuration tree and is executed asynchronously. That means we fill up a newsletter synchronization queue, and this queue is then processed via a cron job. The second part is about the export of newsletter templates. That means it's possible to create the newsletter templates directly within Pimcore, use all the data that is available in Pimcore, like the assets, like the structured data, and then export the finished template to the newsletter system and use it for the campaigns there. For details for all these integrations, have a look at our documentation. Another quite handy feature the CMF provides for newsletters is the so-called link activity tracking. This allows you to create links that, once a customer opens them, track an activity right away for this customer. Let's go back to our demo application and see how this works.
For defining link activity definitions, we need to create data objects of the type link activity definition. This data object then contains all the information and parameters that are needed for building up the link. First of all, we have the type parameter, which also defines the type of the activity that is tracked on the customer. Then we can define some label, for example. We can define some Google Analytics campaign tracking parameters, and we also can define custom additional attributes that are added to the link. Then, of course, we need to define the landing page link to which the link activity definition should point at. Let's just use a document for that. And then save the link activity definition, and we are done with defining the link activity definition. Next step is to use it, and for that we go back to our newsletter we created before and just drag and drop the link activity definition object to the place where we want to put the link to. There, of course, we can then customize the label of the link and also place content around it as we need it. And the most important thing though is that the link in the background that is generated is based on the link activity definition and points to the customer to the defined landing page. Let's test this. Just send this newsletter. I prepared there a special customer type so that we can restrict the customers to a certain list of customer, or just one customer actually. And now we send this newsletter to this customer. And now we just open up the link here. And when we open up the link, we see that the customer is redirected to this classic cars on sale page with some additional parameters. And when we now go back to the customer, which is the Dino Flintstone, and open the activities of the customer, reload them, then we see that the special offer page activity is tracked here with the corresponding timestamp and also with the additional label we defined in the link activity definition. So this is a quite powerful tool to track the engagement of newsletters you are sending directly out of Pimcore and see what your customers click in this newsletter.
Next, I want to show you a few showcases to give you an impression of what can be done with Pimcore, what solutions can be built with Pimcore, and what Pimcore is actually used for. The first showcase is Bösch, which is an Austrian-based B2B company that sells heating devices to plumbers, and for them we created a B2B shop system to sell these heating devices. Of course, as heating devices are quite complex products, these products have to have many attributes. We manage them all within the Pimcore PIM system, within the data objects, and provide all the information in the shop and allow the users to buy these complex products. In addition to the products themselves, there is also a tool that is called System Finder, which allows the plumbers to configure, based on a few questions and answers, a system that only consists of parts that fit together, meaning you have some heating source in the basement, you have maybe some solar panels on the roof, and of course you need to set up the system that all the parts fit together with all the necessary accessory parts, and this is what the System Finder actually does. It provides you a part list of all the necessary parts to install the heating system. And all the necessary relation knowledge, all the knowledge graph is of course managed within the data objects of Pimcore. In addition to the system finder, there are also a few other tools like an end customer offer tool where the user, the plumbers of this platform can create offers for their end customers, and an additional very important part of this whole portal is the web to print module, which is used to create the print catalogs of Birch, which have about 700 pages, and all these catalogs are created directly within Pimcore, of course, by using all the product information that is already stored in the data objects for the B2B shop. And yeah, the catalog is then directly created within Pimcore. Another showcase is some kind of similar showcase, but still a very different one. It's Frischeis and all the connected companies. Frischeis is a, again, Austrian and Eastern Europe based company that sells anything that has to do with wood, meaning floors and doors and construction wood and these kind of things. And for them, we also created a multi-tenant, in this case also multi-country B2B shop system, again with a lot of additional tools like end customer offer tool, invoices, user management, all these kind of things. And this platform has about 250,000 products and about 10,000 customers. And as B2B systems often have, we have, of course, customer specific prices and assortments, which means, yeah, this is quite a huge amount of data. We integrated also some external tools here, like for example, this floor studio, where the user can simulate certain floors in this room view, and yeah, the data for all this rendering comes again out of Pimcore. So all the product information, all the asset information, so all the images and these kind of things. And of course, then once you have found your floor that you want to buy, you can put the floor back into the cart of the B2B shop and order it right away. In addition to the floor finder, we have some other tools like Finder that allows you to find the wanted products. We have a portal where the user can log in, have some kind of welcome dashboard which can be configured, all these kind of things. And we also have web to print in this case. In this case, a bit different. We do not create the catalogs, but we create price lists. Idea behind this is that Frischeis has quite a wide assortment, and a lot of customers only need some special parts of this assortment, and therefore they can here select which product categories are interesting for them and then create a price list that is really fitted for their needs. They only have the products they need, and of course they have also their prices listed in this price list. So this is an on-the-fly generation of a price list. The third showcase is another project. It's more a PIM specific project, which is in this case for Intersport, a PIM for all the exclusive brand products. Intersport has a couple of exclusive brands where they are also the manufacturer for, like McKinley, like ProTouch, like Firefly, and these kind of things. And for them, they have, of course, also to create the product data. And for this creation process, we created a Pimcore solution that supports them by defining so-called work packages, which are products for a certain season and of a certain category. And these products go through a product data creation process. And you have, of course, some overview pages here in Pimcore backend where you see which work package is in which state of the workflow. You have some detail pages for these work packages where you have a product list of all the products that are in this work package, and also again some overview of what is already there for these products and what needs to be done. Then, of course, we have again Pimcore data objects that hold the data. In this case, we are also using a concept that is called custom layouts to provide different views on the product data. Depending on the workflow state, different data is relevant and different data is not relevant. And so we only show, of course, the relevant data and the relevant data attributes to the users of the current state. In addition to the data creation process in the Pimcore backend, in this case, we also have an external interface, in this case, the texter interface, where external persons that just write the texts for the products can log in and have a really optimized view for just their only tasks of writing texts. And yeah, it's really stripped down. It's really just what they need. They have the information in terms of the product information, and they have their two text fields here where they can put in the text, and they have a preview where they can see how a product data sheet would look like with their text. This is actually a best practice approach that we follow quite often, as we provide additional interfaces, additional views on the data of Pimcore, and use the Pimcore API to create these interfaces. And since this Pimcore API is quite powerful, this is something that can be done quite easily. And yeah, you can therefore create optimized portals for all the use cases that you might need to support. In addition to the actual product data creation process, there is also some kind of user interface where different stakeholders within the Intersport group can log in and collect product information data, also collect additional assets like pictures, like marketing material, all these kind of things, put these things together in a so-called basket, and then download all the product information data. That were the three short showcases I wanted to show you. They should just give you a quick impression and idea of what solutions can be built with Pimcore, and these showcases are only built with Pimcore. There is no other external system integrated.
Finally, let's have a look at the Pimcore developer ecosystem, where to get information from, how to communicate, how to contribute, and also in general where to find Pimcore related resources. There is this whole list here, and first of all, of course, there is the Pimcore documentation, which tries to explain how to work with Pimcore, how to use the Pimcore modules, and in general tries to explain all the Pimcore concepts. And so this is of course the first place when it comes to learning Pimcore and getting to know how things can be done. When it comes to core development, then GitHub is the place to go, as Pimcore development takes place at GitHub. That means all the source code development, but also all the issue management, the release planning, and of course all the contributions in terms of pull requests are taking place on GitHub. Pimcore is an open source project, so therefore it lives from its contributions, and we are really grateful for all the contributions that we can get, that are not only contributions in terms of source code via pull requests, but also in terms of issues, in terms of documentation improvements, which by the way also can be contributed directly at GitHub. When it comes to the communication with the community and getting information, getting tips, etc., there are two places to go. First place is our forum, which we recently moved to GitHub discussions, and which is a more persistent way for communication and getting information. And then second, there is this Gitter channel for Pimcore, which is a more live communication with the community. Then Also, our demo application is available for download, so you can use it for playing around and also see it as a kind of a blueprint application for learning how things can be done with Pimcore. Then there is a marketplace which lists all the extensions that are available for Pimcore from the core team as well as from the community. Actually, the marketplace gets all its content from Packagist, so it is kind of pre-filtered Packagist listing which lists all the Pimcore extensions. And in addition to all of that, there are two more channels, like our blog and the Twitter channel, which are of course used when communicating new releases of Pimcore, for example, but in general, these two are more marketing channels for marketing communication. And last but not least, if you need any additional support or services, then we also offer professional services. Just have a look at our website for the most current information on our offerings.
Hello and welcome to this session of Pimcore Insights. This time it's all about the basic concepts and the philosophy of Pimcore. Pimcore, Own the Digital World, is our claim and our vision, and we see Pimcore as a platform that integrates two major parts, the data manager and the experience manager. The data manager is all about managing and consolidating any data. And the experience manager then uses this data and delivers user experiences to any channel. And Pimcore is the platform, the open source digital platform that integrates these two major parts. If we have a more detailed look at the two parts, we see that Pimcore actually integrates four major modules. On the data manager side, we have the PIM or Master Data Management module and the Digital Asset Management module. And on the Experience Manager side, we have the CMS or Enterprise Content Management module and the e-commerce module to build e-commerce applications. Actually, there are two major approaches for digital transformation projects. One is the best of breed approach, which means to select separate specialized systems for all the needed areas and modules and connect these systems with each other via interfaces. And the other approach is the integrated approach, which follows Pimcore as it integrates all these modules into one platform, into one system, and this is one of the major USPs of Pimcore. Around Pimcore, there already has been developed an ecosystem with additional services, product extensions, cloud services, and also an international partner network. That means Pimcore is not anymore the small open source platform at GitHub. It's already a big player and a big product in terms of ecosystem and in terms of services. Let's strip the marketing colors a bit aside and see what Pimcore is more from a developer perspective. We say Pimcore is one platform for any data, for any channel, for any process, and for anyone. In the data manager, you can manage any kind of digital data. You can deliver this data to any channel. You can build up any process with Pimcore, and since it's open source, you can provide it to anyone and anyone can use it. Pimcore is an integrated software stack for CMS, DAM, PIM, and e-commerce, and provides a solid foundation with generic functionality for web applications. And it allows you to build solutions in a rapid application development approach. And one of the key aspects, one of the key concepts for doing so is the API-driven approach of Pimcore. That means that everything that can be done in Pimcore backend via click, via drag and drop, via inserting data can also be done via the API can be automated, and that of course make Pimcore easy extendable and also easy to integrate into existing IT infrastructures. On the other side, what is Pimcore not? Pimcore is not an out-of-the-box software product like WordPress, Magento, Oxid, or Microsoft Word that you install and have your finished solution ready. Pimcore is a platform, is a framework where you need a developer to get started and build up your customized solution for your specialized use cases.
So far, you have learned how to create API endpoints in Data Hub and about schema definitions, which defines data set that you can query from API. Next step is to learn how to configure these schema definitions. So let's take a use case based on a demo data. Suppose we want to fetch products data and its color variance from Data Hub API. So we have a product here with some attributes like name, description, manufacturer, body style, class, production year, color, and we have color variants for this product with some media images. So now let's see how we can create an API endpoint to fetch this information. So I'm going to use an API endpoint that we have created in the last part. So I'm going to schema definition here. So now to fetch the information from Pimcore, we need to define a query schema. So I'm going to add car entity to this query schema. Click OK. Click Settings to open Query Schema Definition window. And on the left-hand side, you see class definition attributes. And we can add these attributes to the query schema dataset so that user can query these attributes from the API. And we can also define some formatters and transformers to change the value in the API response. So let's add some attributes. And some image attribute also, and click apply. So once we are done with adding attributes to the query schema, next step is to define the workspace permissions for the folder from where we want to fetch the objects. So we want to add the cars folder to this workspace's permissions, and we will allow read permission on this so that we can read objects from the cars folder, and click save. Now that our API endpoint is saved with query schema definition, it's time to form the query and test the response in iExplorer. Let's write a query to get the car object. And we need to provide an ID here to fetch the car object. And we also need some information for this object like name, description, car class. And we also need information about the color variance. So for that, we need to call children, and we need to use GraphQL fragment to fetch the children objects. And we will also request some information for the children's like ID, color, and gallery, which is a collection of images. And for the image, we need full path. So now we are done with forming our query to get the car object and its color variance. So now execute the query. So you see we have the response, but if you look carefully that the images are still null in the response. And the reason is that we have not added the workspace permissions for the assets. So we need to provide permission for the car images folder so that we can read images from this folder. So let's click save and let's rerun the query. Now you see that we have full path of the images here in the response. So if you look carefully, we have the original images that was uploaded in the Pimcore, but sometimes it is required to fetch the optimized version of the images. So for that, we can use thumbnail parameter, and we can provide a name of the thumbnail. So we are going to use thumbnail that is already defined in the system. So let's pick one thumbnail here, product detail. And let's run the query. So now you see that we have the optimized version of the images. Now let's try one of the transformer. Our description is too long for the API response, so let's make it short with the help of transformer. Let's go back to Data Hub config and settings. And let's select substring transformer from the list. And let's provide the same name as of the field. And we need to define the start point for the substring and length. So let's say we want to make it short to 50 characters. And then we want to have ellipses after that. Apply. And then we need to drag drop our field under the substring transformer and apply. Now let's rerun the query and see what we get in the response. Our description is cut short with the number of characters defined in the transformer config. In the last part, we learned how to configure query schema and how to fetch a single car object from Data Hub API. Now let's see how we can query a list of cars from the same API endpoint. So let's say we want to fetch this information from our API endpoint. So let's go to AI Explorer. As you can see, I've already formed the basic structure of listing query here. Let me explain these terminologies. So car listing is a connection, which is a collection of records. A node here represents an entity, which is a record that holds the information. An edges represents the connection between the records. And it also holds some metadata like cursor, which is a pointer to that node. So let's define some attributes here that we want to fetch from the request, like ID, name, description, and car class. So now let's run the query and see what we get in the response. So we get complete list of cars in the response. And let's say we just want 10 records per request. So for that, we can provide pagination parameters. So first, let's see what parameters we can pass to our listing query. Going to documentation. So you see here, we can provide IDs, which restricts the result to particular IDs. We can also provide default language to change the language for localized fields in the response. We can provide pagination parameters like first, which is a limit for the total number of records, and after, which is an offset. And we can also provide some sorting parameters like sort by and sort order. And we can also add some additional filters with the filter parameters. So now let's add paging parameters to our listing query. First, which is a limit for our records in the list, and after, which is an offset. So let's run the query. Now you see we have 10 records in the response, but still the records are mixed up. Like we have sports car, we have mid-size luxury cars. So let's see how we can filter these records. So for that, we can use filter parameter. So let's go to documentation and let's see how we can provide that filter. So let's copy the filter structure from the documentation and let's paste it here. And now we want to apply this filter on car class property. And we want to just have sports cars in the list. Now let's run the query. And now you see that we have all the sports car in the list.
Hello and welcome to this session of Pimcore Insights. This time it's once again all about the documents. In the first part I want to discuss one special edit table which is called renderlet. With renderlets, your editors can drag any data element like data objects, like assets, also like other document snippets into a document and render them right away. To do so, a renderlet needs to define a controller action who does the actual rendering. Let's have a look how this is done and create a simple sample renderlet.
In our demo application, we have, for example, event objects that describe an event. So there we have some title, some description, we have also some images for these events. And yeah, let's just create a renderlet that allows us to drag these event data objects to our documents and render the content of the data object directly within the document. To do so, let's just switch into our IDE, and there I already prepared an area brick, which is the demo area brick, pretty much a default area brick with no additional logic in there. And of course, this area brick also has a corresponding view script, and in this view script now we define our renderlet. To make look it a bit nicer, we just also add a couple of additional markup here with a couple of HTML containers that we place it nicely in the whole content. And we also not just add one renderlet, but multiple renderlets, 3 in a row, and that's the reason why we have a simple for loop here where we add the renderlets now. The renderlets themselves are added as any other editable of Pimcore. So we have this Pimcore renderlet function here where we need to define a name. The name needs to be unique, so we just append the loop index to it, and then we also can define additional settings for the renderlet. There is one mandatory setting, which is the controller setting, and this controller actually defines what controller action is responsible for rendering the content that is assigned to the renderlet. So there we, for example, just define our default controller, and we will add an additional event action to this default controller, and this event action should then be used for rendering the content of the renderlet. Then there are some additional settings which might be quite useful. For example, we can define the height, which defines the height of the renderlet in the edit mode. And we also can define, for example, a title, which is also shown in the edit mode and gives our editor some hints. For example, drag an event object here. There are also some additional configuration options. We have them all documented here in our documentation. Additional quite useful are maybe the type setting here, which allows us to restrict the type of the element that can be assigned to the renderlet. So we can define here document, asset, or data object. And if a data object is assigned, we also can check for the class of the data object. So we could also restrict the assignment just to one data object class. And yeah, so much for defining the renderlet itself. What we now need to do is then create the specified controller action. And this controller action then actually gets the assigned content as parameters in the request object. And these parameters that it gets are the ID, are the type, and also the subtype. So we need to create a controller action in our default controller, which is default controller action, so public function event action, for example, and we now just assign ourselves the request here so that we can retrieve the data that is assigned from the renderlet here. And there we first check if the assigned data is really a data object, so we check for the type, which needs to be an object. And if it's an object, then we check if it's an event. So we just assign this to an event variable if it is an event, and the event we just load by the getById function, and we get the ID again from the request here. And if we have an event here, then we render a script and return this as the result of the request. So let's just render a view and assign the event object to the view here. The view will be a standard Symfony view. Just now create this already, and we need to create the view itself then later on. What's missing there is that if either no data is assigned or not an event is assigned, we need to throw an exception or just return an error message. Let's just return an not found HTTP exception, where we say event not found, so that we get some kind of an error message. So much for the controller itself. Now we need to define the template, and there we just create a new file, which is the event html.twig file, and this template now defines how we want to render the event data. For that, I again have prepared some markup to make it look a bit nicer. And yeah, in this markup we have a couple of placeholders where we just now access the event data and, for example, print out the title or print out the description here. For description, maybe we strip the tags, because this is what you see is what you get field, and we also limit the length to, let's say, 150 characters, and then we just add a couple of points there so that it looks a bit nicer. And then we also want to print out the image, and for that we first check if there is an image assigned to the event data object, and if so, we want to print the image in a certain thumbnail. And there is actually also a helper function that makes it a bit easier for us, which is the Pimcore image thumbnail HTML function. And there we just assign the image, we define the thumbnail we want to have. And last but not least, we also want to define a couple of options to make sure that the image has assigned a certain CSS class. And for that we need to assign image attributes. And there we define that the class should be image fluid, so that this works properly. And that's already about it. Let's go back to the Pimcore backend and see if all is working out. So let's just reload our Academy document, check if we can add our Academy brick. And there we see already that we have all the different renderlets here, these 3 in a row, and now we can assign the data objects for the events. Renderlets have a pretty simple principle, but they produce quite a powerful output. Actually, what you are allowed to drag here and what you do with the content is really up to the developer who creates the controller action, who renders the content then. So of course it's not only possible to assign their single data elements, you also could assign whole folders, either data object folders or, for example, also asset folders, and then the renderlet creates a gallery based on all the assets that are in this folder. So the level of automation can be really great with these renderlets, and so they are on the one side a really powerful tool for making life easier for the editors, and on the other hand, they are a quite powerful tool when it comes to pitching, showing off, and also showing the possibilities how to connect the documents with data objects and with assets.
With the site functionality of Pimcore, you can set up multi-domain web applications with just one Pimcore instance. A site can set up again based on the tree and makes one subtree available under a certain domain to the outside world. Let's just set up the DE subtree as a site with this user site option here in the context menu and specify another domain.com, for example, as the domain. You can optionally define additional domains, can specify if all additional domains should be redirected to the main domain, and specify a separate error page. In general, sites are some kind of tenants within Pimcore, and many of the options you can specify within the user interface of the Pimcore backend are site specific, like settings for tracking information like Google Analytics or Matomo, or website configurations. All these things can be specified site specific. Once a site is set up, Pimcore checks under which domain a certain request reaches the Pimcore server and depending on the domain delivers the correct content. For example, when I now open up another domain.com, Pimcore automatically delivers me the German portal page. And of course, when I open up any subpages, the URL of these subpages is then relative to the site node within our document tree. Like we see it here, DE is our root node for a certain site, and then, for example, this Einführung document is the first level below our root node.
The next thing we need to discuss is how Pimcore stores the assets. This is already mentioned in the system architecture session, that Pimcore not only uses the database, but also the file system as a primary data source. That's because assets are not stored as blobs somewhere in the database, but are stored directly on the file system in a certain folder. This folder is located in the public var folder, which is also explained in the installation package session. And there is an asset folder, and within this asset folder, you have a folder structure which is the same as the tree folder structure in the assets tree. And below these folders, you will find the original binary files of the assets. These files are the primary source that Pimcore loads when the assets are open for editing in the admin backend. So don't mess around with these folders. A consequence of this architecture is that once you have a certain URL, anyone with the URL can access these assets. The public URL we already saw in the system information window here. Once this public URL is known to some external person, it can open up the URL and open up the asset. This is important to know because you cannot manage secret information within these assets without having any additional configuration within Pimcore. There are multiple reasons why Pimcore manages and stores the assets directly on the file system. First of all, that we don't want to fill up the database with huge blob data. And the second thing is performance reasons, because delivering files directly from the file system is much faster for a web browser compared to loading it from a database, passing it through PHP or whatsoever, and then delivering it via PHP. If you want to manage restricted assets and assets that should not be available to all public, there is a special configuration possibility that you can use, which is explained in our documentation. You can find the information under Assets, Restricting Public Asset Access page in the documentation. The idea behind these configs is to define a certain rewrite rule in the STXS to protect either certain folders within the assets or restricting access to all the assets. But it's important to know that these configurations will have impact on the performance and also on the server load itself. In background, Pimcore uses a powerful file storage library called FlySystem, which is a PHP package for managing your file storage on different file systems. Pimcore FlySystem integration provides a configuration for managing different content files like assets, thumbnails, versions, recycle bin items, and so on. So you can use different file system adapters for custom storage of your files like local file system, SFTP, AWS S3, and so on. So let's take an example how you can manage your assets on cloud, in this case AWS S3. To achieve this, you need to define first AWS S3 client service with configurations in argument like endpoint, region, version, and credentials. Once this client service is defined, next step is to override Pimcore asset storage default config. This is the default config used for storing assets in Pimcore application. So you can use a custom adapter. So in this case, AWS, and providing client service in options and also the bucket name to be used for storage. Along with custom adapter configuration, you also need to define specific front-end paths so that Pimcore knows how to serve data from cloud path when requested on Pimcore API.
Hello and welcome to this session of Pimcore Insights. This time it's all about how to get started with Pimcore. First of all, we need to discuss the system requirements. Pimcore is a web application and therefore it has quite typical system requirements for PHP-based web applications. We have listed them all in our documentation and well, let's have a look at the documentation.
First of all, you need a web server, and as web service, Pimcore supports either Apache or Nginx. As application server, PHP 8 is required, or newer versions of PHP, and there are a couple of required extensions and settings for PHP and a couple of recommended modules and extensions. If these recommended modules are not there, Pimcore still will work, but the corresponding features are not available. A very important module of PHP is Composer, which we require for installation and for all the dependency management. As database server, Pimcore requires a MySQL database or a MySQL compatible systems like MariaDB or Pimcore server, and also of course compatible cloud database systems can be used. As cache backend, Pimcore uses Redis. Actually, it's just optional because there is a database-based fallback for caching, but at least in production systems we highly recommend the use of Redis because it really improves the performance a lot. Operating system wise, Pimcore is quite flexible, but we highly recommend a Linux-based or even better a Debian-based operating system. But in times of Docker, of course, the host operating system does not matter that much anymore. Again, we have some additional software that is required for Pimcore, or at least recommended to provide the full-featured Pimcore experience. As Pimcore is a web-based system, also of course the admin user interface is started in a browser. And for this admin user interface, we have some browser requirements. We support all the 4 major desktop browsers in the latest 2 versions. Important to know is that these browser requirements only apply to the administration user interface and do not apply to any frontends that might be implemented with Pimcore, since frontends are implemented by you as a developer. You define what browser requirements you have there and what browsers you are going to support. To ease up the setup of the system environment, we also provide Docker images that you can use for your environment.
Let's leave the templates for a while and have a look at documents in general. Documents are, as already mentioned, organized in a tree. But this tree not only has this organizing function, but also defines the sitemap of a website, and therefore also the URL under which a certain document is available to the outside world. For example, let's have a look at our Academy document we created before and publish this and open this up in the browser. And there we see that the URL of our document is en and academy. And this URL is created based on the position of our document in the tree, which is below the en node and then the academy document. So the tree basically defines which URL which document has. There is one exception to that though, which is called pretty URLs. And these pretty URLs can be defined in the CU and settings tab of the document, where you have this pretty URL and URL slug, and there you can define a pretty URL of the document which overrides the default URL which is defined through the tree. For example, let's say you want here a landing page, and say our Academy document should be just reachable under /landing page. And when we go back to the front end and also try to open up the old URL of our document, Pimcore is redirecting us to the new URL, which is the landing page, and from now on delivers our content just based on this pretty URL. Be careful though for defining too many pretty URLs, because at some point you won't be able to find the corresponding document anymore. But actually Pimcore is providing here maybe a quite useful feature, because with this open document dialog you can provide any URL, and Pimcore is also considering the pretty URLs at this case. So if you just paste in there the pretty URL, Pimcore looks for the corresponding document and opens up the correct document where you can then define your changes or whatever you wanted to do here. Besides the URL, of course, also the navigation is based on the tree. And when you set up the navigation of your website with the Pimcore navigation helper, this is also based on the tree and the tree structure you have defined with your documents.
Before we have a detailed look at the navigation helper, we need to discuss another feature first, and this feature are the properties. Properties are available not only for documents, but also for assets and data objects, and are a quite generic feature to add additional information to elements in order to influence the behavior of your application. It's important to know that there is no default behavior that you can influence with properties, so there are no default properties, but that you always need to take care of properties and the property values in your application code yourself. That means in places like your controllers, your templates, your services, or wherever you want to take care of the property information, you need to take care of the properties that you define. Properties can be added in two ways. First way is to just add them inline here in this properties tab by defining a property name and a property type. There we have 5 types available. We have standard text properties, we have links to other documents, other assets or other data objects, and we also have the possibility to define checkbox properties. And yeah, as soon as you add them, you can specify the value, and as soon as you save the document or in general the element, then the property is added to the element. The second way that you can use to add properties to elements, for example to documents, are so-called predefined properties. And this is actually pretty useful because, as I mentioned before, there are no default properties or default behavior changes you can do with properties. So you always need to take care of the properties within your code yourself. And so you also somehow need to tell the editors and all the other users of the Pimcore backend interface which properties are available, which properties you are listening for, and which properties they can use. And for that you can define so-called predefined properties. So you can tell your editors already which properties they can use and what they can do with these properties. As soon as the predefined properties are defined, you can just add them here with this combo box, and they are defined in the Pimcore settings dialog here in this predefined properties dialog, where you can define all the properties with name, with some description, of course with the type, and you also can restrict the content type, so you can define exactly for which content types this predefined property should be available. Another quite important feature for properties is that they can be inherited. This can be specified with this inheritable checkbox here, and as soon as this checkbox is checked, this means that this property is inherited to all the children documents of the current document. So for example, you can define on your root nodes or some parent nodes properties that then they are assigned to all the children documents, and the children documents then have the possibility to override these properties. In our Academy document, we already see that there is a whole list of inherited documents, and yeah, we can also override these properties. Next, let's have a look how you can take care of property values in your application code, and for that we switch into our IDE and have a look how we can access property values in controller actions. as soon as your controller extends from the standard Pimcore frontend controller, there is a special class property which is called document, and this document has always assigned the current document of the request. And this document is nothing more than a data model for the current document, which has a couple of getters and also setters, but one getter is of special interest for us now, which is the get property getter. And this getter now allows us to load a special property of the current document. And so we can assign this to a variable, and then we also assign this variable to our template. And now we can, for example, access this information here in the template. For example, just print it out, which is just a very simple use case for now. But of course, you also can use this variable now for any conditionals, for any loops, or whatever you want to do with this property value here. And yeah, let's just have a look if this is working. And there we see that our property value is now printed out in the template. Of course, we also can change the value now to some other value, for example, and save the document again. And then we have the other value here printed in our document. Besides accessing the properties within your controller, you also can access them directly in the templates, as also the templates have this document variable available. So we can just use document and then access the property getter, and there, for example, defining again our foo property that we want to load here. Let's switch back and see if it still loads. Yes, it still loads. And so you also can access the property values directly in the template without the controller. Right now, this is really just a very simple example of using properties. We're just printing the values directly out to the template, and this is actually not really a use case. Most of the times, property values really influence the behavior of the application or the user interface or the template of your application. And so there we have also a couple of these properties available in our demo application where we can really change the behavior, like for example hiding or changing the header color or showing or hiding the left navigation here. So let's maybe just change a few values here, save this, and if we now reload our page, we see that actually really the behavior and the appearance of our document changed. So properties really can provide the possibility to editor, to any Pimcore backend users to change the behavior, change the appearance of the application without actually changing any of the business logic, and so providing the editors with additional flexibility for changing behavior and appearance of the documents or the application in general. Now finally, it's time to discuss how to set up website navigations with Pimcore. Pimcore provides a navigation tool which allows you to create navigations like the stop navigation here, like sidebar navigations, and also like breadcrumbs, all based on the Pimcore documents tree. As mentioned already in earlier courses, the Pimcore documents tree defines the sitemap and the structure of your website. And as a consequence, of course, also the structure of your navigation. You have a few options though how you can influence the behavior of the navigation building, and these can be found here in the Navigation and Properties tab on the right side, where we can define a name for the document in the navigation, where we can apply an additional title, where we can define the target for the link, and where we also, for example, can exclude certain documents from the navigation. For example, let's just include this Academy document from our navigation and reload the document, and there we see that now the Academy document is gone from our navigation. The navigation helper itself is documented quite extensively in our documentation and is of course something that you need to integrate into your templates. So this does not come out of the box. And when you integrate it into your templates, then you have to follow 2 steps. The first step is to build the navigation. This can be done with this Pimcore build nav function, which expects 2 parameters. The first parameter is the active document, which is the document that should be marked as active in your navigation. And the second parameter is the navigation root document, which is the document from which the navigation should be built up. And then once the navigation is built, you need to render it with this Pimcore render nav function, and this actually produces some markup which you can then style for your custom needs. Let's maybe discuss a bit more about this navigation root document. And actually the reason why we discussed properties first is that this is a typical use case for properties. So properties are a typical way of how to define this navigation root document. And when we go back to our demo application and have a look at the properties here, there we see that we have there 2 properties. We have this navigation root property and we have this left nav start node property. And these 2 properties define the root node from the top navigation, which is the navigation root property, and the left nav start node is the start node for this sidebar navigation here. In this case, both root documents are the same because they are built based on the same root node, based on this EN node. But when we have, for example, a look at the magazine document here, then we see that the left navigation should contain not the root documents, so not the first level documents here, but it should contain all the children documents of the magazine document. And so when we have a look at the navigation and properties tab here, there we see that the navigation root itself is still the /en, but the left nav start node here is then really the EN magazine document. So this tells the left navigation that it should be built up based on the magazine document as a root node. Of course, we now could change this left start node, for example, and use, for example, this find and buy document, and just again reload the documentation, the document here. And there we see that our left navigation now contains not the sub documents of this magazine document, but the sub documents of this find and buy document, which in this case doesn't make any sense, but still shows how we can modify and influence the behavior and the building process of our navigations. Let's quickly have a look at our templates and see how navigation is set up there. As navigation is something that you typically need on all the pages, navigation rendering is typically located in the parent templates. In our demo application, we call the parent template layout.html.twig. And in our layout template, we already starting here with the top navigation, where we load the property navigation root as the root node for the navigation with some fallback logic, and then we are building up the navigation based on the active document, the current document, and the root node. And then a bit further down, we are rendering the markup of the navigation. The same goes for the left side navigation, a bit down here, where we are again loading the property, having some fallback logic, then building up the navigation and rendering the markup of the navigation. The navigation itself offers a lot of additional features like caching features, like changing the markup and classes that should be added to certain markup elements. Of course, you can also build up breadcrumb navigations, and also you even can add additional navigation items which are not based on the document. And actually this is something that we are also doing in the demo application, where we have this additional navigation extension, this Duke extension, where we're building up the navigation based on category data objects. And for that we actually just using the build method of the navigation helper and defining a page callback. And this page callback checks for every document if the document has a property set that defines a certain property as an entry point for category objects. And then also we additionally checking the root category based on which we want to add the navigation items. And then based on this root category, this callback here adds custom items to the navigation based on the category data objects. And in the layout, we are normally using not the standard building method, but our custom method for building up the navigation here. And when we now switch back to our application here and have a look at the navigation here, there we see that additionally to these two documents here in this find and order menu, we also have categories and spare parts which are based on the category data objects which are built with this custom extension here. This is all documented in the documentation with some more possibilities and additional performance tweaks and these kind of things. So have a look at the documentation for more detailed information about navigations.
The activity store is responsible for loading activities from and storing activities to a data store. This concept allows to use different storage systems like SQL databases, non-SQL databases, or any big data technologies for activities. By default, the Customer Management Framework uses a MariaDB specific adapter that utilizes the dynamic column feature of MariaDB for the activity data array. As an alternative, the CMF also ships with a standard MySQL adapter, and by implementing the data activity store interface, it is easily possible to provide any custom implementations for the activity store, for example, based on Elasticsearch or something else. To see how to configure a custom implementation, let's have once more a look at our demo application, where we use the standard MySQL adapter instead of the MariaDB adapter to avoid the dependency on the MariaDB. And yeah, this is done by simply overriding the service definition for the activity store interface and provide the custom implementation class that should be used.